All right, number 2. It says in circle W, YZ is equal to 18, UX is equal to 10, and arc UX is equal to 80. That should be 80 degrees since it's an arc. Find the measurements below. Round answers to the nearest hundredth if necessary. So when I look at circle W, the first thing that catches my attention is this right angle marking right here. What would we call segment YZ in the circle? That's a diameter. When a diameter or a radius makes a right angle with a, what is this guy? A chord. When a diameter or a radius makes a right angle with a chord, it bisects the chord. It cuts it in half. It also cuts the arc that that chord is intercepting in half. So because of that right angle symbol, I know that UV and VX are the same size. I know that arc UY and arc YX are the same size. Again, all of that is coming from that right angle mark right there. And now looking at the information that they've given me to work with, it says arc UX is 80 degrees. So from here over to here is 80. So how big is each little arc? 40. That is actually one of the questions that they ask on this one. It says the measure of arc UY. Well, the measure of arc UY is equal to half the measurement of arc UX. So the measurement of arc UY is equal to half of 80 degrees. So arc UY is 40 degrees. All right. So there's the first piece that we're going to do. The first thing that they actually asked us for was oh wait, I haven't finished looking at all of our given information yet. My bad. Says UX is 10. UX is this whole chord. How big is each portion then? 5, because it's being bisected. So 5 and 5. And then they tell us that YZ is equal to 18. What did you call YZ again? A diameter. Well, if the diameter is 18, how big is the radius? 9. So from W to Z is 9. From W to Y would also be 9. Correct? Cool. All right. Now we get into what they want us to find. They want us to find VW, which is this right here. Is VW the whole radius? No, it's part of the radius. When they want us to find just a piece of the radius, not the whole radius, but a part of the radius, we're going to try to make a right triangle so we can use Pythagorean theorem. I see a right angle right here, and if I draw in my own radius from, say, W to U, or I could go from W to X, I know how big all of the radii in this circle are. How big are all of the radii? 9. So this is 9 here. And now I have a right triangle. Oops, that's not what I wanted to do. I want to erase this for right now. Now I have a right triangle that I can use to find the length from V to W. So Pythagorean theorem gets broken out. A squared plus B squared equals C squared. What part of a right triangle has to go in for C? Hypotenuse, which is 9. You guys are absolutely correct. I got both right answers. So I have 9 squared over there on a side by itself. So what goes in for A and for B? 5 goes in for one of them. I'm going to put it in for B. And X. Or we could give it the name VW. I'm fine if you call it X. I'm fine if you leave it as A. Or you can put in the name of the segment that we're looking for, which in this case is VW. And that's what I'm going to do on this one. So I have VW squared plus 25 equals 81. And then I'm going to subtract 25 from both sides. And so I get VW squared equals how much? 56. Now what do I need to do? Square root both sides, absolutely correct. If you do it to one side, you got to do it to the other side. Why are we doing this? Yes, so that we can get rid of the exponent. We can get rid of the squared on the VW. Squared and square root cancel each other out. So now I have just VW by itself. What is the square root of 56? 7.5 if you round it to the nearest tenth. 7.48 if you round to the nearest hundredth. 7.483 if you take it out to 3 decimal places. I would not count it wrong if you said 7.5. However, it does say to the nearest hundredth, which is 2 decimal places. So there's my VW. So we know this much right here. This is 7.483. What's the last thing they want me to find on this question? They want me to find YV, which is this bit right here, which is the rest of that radius, correct? The radius there would be WY. WY has been broken into these 2 parts. It's VW and YV. We know how big the radius is. We know how big it is from W to Y. How big is this? 9. So 9 equals, we just found VW. That was 7.483 plus YV. So then I'm going to subtract 7.483 from both sides. What is 9 minus 7.483? Nine minus 7.483. $1.517 is YV. Did that process make sense? Remember, if they want you to find part of a radius, try to make a right triangle so that you can use Pythagorean theorem. If they want you to find the other little part of that radius, after you found one piece, if you know how big the radius is, then you can just subtract what you found from the whole radius to find that other little part. All right. Number 8 was the next one I was asked for. We're going to do 8 and then 13, and then I'll open it up to questions again. Yes. You got one person in front of you, and then you may go. All right. You're welcome. Number 8. This guy right here. Says use the diagram below to find the following measures. So when I look at this, I see this circle has been kind of all chopped up with angles. What do we call angles that have their vertex, their point, right at the center? What do we call the angles that have their point at the center of the circle? What type of angle is that? It's a central angle. Central angles have their vertex right at the center. So there's a whole bunch of central angles in this picture right here. This is the first one that I'm looking at. This is a central angle because right here is the turning point, the vertex of the angle, and it's right at the center. The measurement of a central angle is exactly the same as the arc that it intercepts. So angle CAD is 50 degrees, which means arc CD is how big? 50 degrees, yes. There's another angle and arc up there that's also 50 degrees. Does anybody see it? BAF, because that is a vertical angle with CAD. So this angle is 50 degrees, and that means arc BF is also 50 degrees. So far, so good? All right. I see a little box right here. What does that mean? It means it's a right angle. How big is a right angle? I got two people in front of you. So how big is arc ED? 90. What would we call segment BD? That's a diameter. And what do diameters do to circles? Cuts them in half. So how big is arc BCD? 180. Well, this much of it right here, CD is 50. So how much is left over for arc BC? 130. 180 minus 50. So how big is angle BAC? 130. Angle BAC is 130 degrees. BD you said was a diameter, which cuts my circle in half. So how big is arc BED? 180 for here. This much of it is 90, right? This much of it is 50. How much is left over for this? 40, yes. 40 degrees here, which means a 40-degree angle here. So far, so good? Right, that's the first thing I do is I'm going to fill everything in on the circle that I possibly can. And then I'm going to come over and I'm going to answer the questions. So first thing they want is angle BAC. How big is angle BAC? 130. How big is arc DC? 50. How big is arc BC? 130. How big is arc FE? 40. All right, then we're back to an angle. Angle BAE. 190 or 90? 90, yes. We add the 40 and the 50 together to get that 90. All right, arc BE would also be 90. Again, we put the 40 and the 50 together. How about arc BED? 180, that's half my circle. And then finally we get to arc CBE. C past B and all the way around to E. 220, tell me how you got that. You added 130 to what? 50 and 40. And when you add those, you get 220. Right. Before we go on and look at number 13, does anybody have any questions about number 8? Remember, central angles, vertex, turning point of an angle. If that's at the center of the circle, then the angle and the arc are the same size. They have the same measurement. All right, number 13. Nobody has asked me for number 13 yet today. You guys are the first. It's a good question. lets us practice several things. We need to find x and y. So let's look at just x for a second. So I'm going to imagine that I can't see any of this. I know that this angle right here, which is a central angle, is 96 degrees. What would I need to do to figure out how big this angle is? Absolutely correct, 96, but yes, 360 minus 96. That equals x. What is 360 minus 96? 264. So x is 264 degrees. That is the first thing they asked me for. All right. Then they want me to find y. Before I find y, I want you guys to tell me how big the arc is from right here to right over here. 96, yes. That would be 96 degrees. Because the 96 degrees right by the center of the circle is a central angle. The point is right at the center. What kind of angle is angle y? Inscribed. The turning point, the vertex, is on the crust of the circle. This is an inscribed angle. When we have an inscribed angle, the measurement of the angle is equal to half the measurement of the arc. Do we know how big the angle is? Y, yes. We're just going to put a y in that spot. So y equals 1/2. How big is the arc that it's intercepting? 96 degrees. So I need half of 96 degrees. What is half of 96? 48. So y is 48 degrees. X is 264 and y is 48. Nicely done. All right, those are the first 3 questions I was asked, and I asked you guys to pause at that point so I could hold all those numbers in my head. What else would you like to see? Number 7, absolutely. Number 7 is a lot like number 8. We have a whole bunch of central angles in the picture. NTM is 48 degrees. So how big is arc NM? 48. How big is arc PN? 42. How big is arc JK? 32. I skipped the one that we don't know. How big is arc KL? 90. All right, now let's go in and figure out the ones that we don't know. What would we call MK? A diameter. What's a diameter do to a circle? Cuts it in half. So how many degrees is it for arc MLK? That'd be 180. Well, 90 of it is eaten up right here, correct? So how big would this arc have to be? 90, because 90 plus 90 gives me 180. So I know that this angle right here is also a right angle. I know of two possible ways to find arc PJ. Who can give me one of those two ways? Yes. Close. Not 180. 360. If I'm going all the way around the whole circle, then I would have to subtract it from 360. I like what you said about 180, though, because 180 is how much of the circle? Half the circle. So if I can find a diameter like this, I know that it's 180 from here to here. That gives me less to add and subtract, and I'm going to get the same answer. We can do it either way. So we're going to do 180, and then I'm going to minus this 90, which leaves me how much? 90, and then I need to minus 32 from that. It is. PL is also a diameter. Goes edge to edge through the center. Yep, those are both diameters in this circle. That's a good observation. How many degrees do we have left over for PJ? How much? Sorry, I thought I heard somebody say it. Close, 58. It says 58 degrees. All right, let's go through and answer the questions now. Arc PML. So starting at P, go past M, all the way over to L. How much would that be? 180, because PL is a diameter. This is 180. Or you could add 42 plus 48 plus 90. That would also give you 180. So you can find it either way. All right, arc JM. From J around to M. How are we going to find that? 180 minus 32. It's half my circle minus that little 32 degree arc. Or I could do what? If I didn't want to subtract, I could add those three, 58 plus 42 plus 48. I can do it either way. I'm going to get the same answer. What do we get for this arc? 148. Are they asking me for an arc on part C? No, now I want an angle. Angle MTL. M to T to L. How big is that angle? 90. All right, and then they ask me for another angle, PTJ. 58. We didn't write it in there, but that's how big the arc is. And this is a central angle, so 58 degrees. Arc NKL, so we start at N. We go past K, and we stop over here at L. How much? Close. Super close. It's not 228, but you're very, very close. $222. How do we get that? Yep, we're going to add 90 plus 32 plus 58 plus 42. Gives me 222. All right, last part of this question. It says, if arc ML equals 5x minus 10, find x. Well, here's arc ML. How big is arc ML? 90 degrees. So this right here is 90 degrees. So I'm going to take 5x minus 10, and I'm going to set it equal to 90. So then to solve this for x, I'm going to add 10 to both sides. What is 90 plus 10? 100. So 5x equals 100. and then we divide both sides by 5. What is 100 divided by 5? 20. So x is 20. Got time for 2 or 3 more questions, depending on how long they are. What would you guys like to see? What'd you say? 4, and you said 24? All right, let's do 4 first, since we're closer to it, and then we'll go do 24. All right. In circle M, JL, so from here to here, is 23. And NT, from here to here, is 3x minus 1. What do you notice right here and right here? Yep. We got right angles, and they're both 5. These are congruent. That means those 2 chords are the same distance away from the center. Does anybody remember what's true when my chords are the same distance from the center? Yes, they're congruent. They're equal to each other. So JL is congruent to NT. So the measurement of JL is equal to the measurement of NT. So 23 is equal to 3x minus 1. We're going to solve this for x, so I'm going to add 1 to both sides. What is 23 plus 1? 24 equals 3x. And then we're going to divide both sides by 3. And we get 8. X is equal to 8. All right. And now 24, which is the very last problem. And I am really glad that we are doing this one. I was really glad that we did number 2, because we had a question like number 2 on the first skills check. And a lot of people struggled with that. And I'm really happy to see this one, because we had one like this on the skills check yesterday. We need to find x and y and arc JK and arc LM. Well, x is right here and right here. X is part of angle J. Here's angle J. And x is also part of angle K. Here's angle K. Both of those arcs are intercepting, both of those angles are intercepting this arc right here. So what does that mean about those 2 angles? They are congruent. So angle J is congruent to angle K. So the measurement of angle J is equal to the measurement of angle K. Angle J is 3x plus 5. Angle K is 4x minus 6. If I'm going to solve this for x, I need my x's on the same side, so I'm going to minus 3x from both sides. That gives me 5 equals x minus 6. And then I'm going to add 6 to both sides. So x is how big? X is 11. They asked me to find arc LM, didn't they? That's the arc that's being intercepted by angles J and K. What kind of angles are J and K? They're inscribed. And when we have inscribed angles, the measurement of the angle is equal to half the measurement of the arc. Since angles J and K are the same size, it doesn't matter which one I choose. I can choose J or K. So I'm going to do angle J. Angle J is equal to 1/2 times arc LM. Angle J is 3x plus 5 is equal to 1/2 of the measurement of arc LM. And x is how big? 11. So I have 3 times 11 plus 5. What's 3 times 11? 33 plus 5 more? 38. So 38 is equal to 1/2 the measurement of arc LM. I want LM all by itself. So what do I want to get rid of? Yes, I want to get rid of the fraction. Multiplication is how we get rid of fractions. We're going to multiply by the denominator, and the denominator is 2. So we're going to multiply both sides by 2. The 2 in the denominator cancels out with the 2 that I'm multiplying by. So there are no more 2's left over on the right-hand side. Over on the left, I have 2 times 38, which gives me what? 76. You divided instead of multiplied. 76 is equal to the measurement of arc LM. If you're looking for the arc, it will be bigger than the angle. If you're looking for the angle, it will be smaller than the arc when you have inscribed angles. So 76 degrees here for this. That was the piece that most of us had the most difficulty with on the skills check yesterday, was finding the arc. We did a pretty good job with finding x and y. Right. We still need to find y here, and so I'm going to erase a lot of my drawing. It's 1/2 of the arc, and we don't know the size of the arc. We know the size of the angle. So because I don't know the size of the arc, I can't take 1/2 of that number because I don't know that number. So then we have to get rid of the fraction, which means multiplying by the denominator. Does that help? Okay. All right, we need y. Here's angle L. And here's angle M. Those are both intercepting what arc? JK. So what does that mean about those two angles? They are congruent. So angle L is congruent to angle M. So the measurement of angle L is equal to the measurement of angle M. The measurement of angle L is 6y plus 3. The measurement of angle M is 7y minus 1. We're going to solve this for y, so I need to get the y's on the same side. So I'm going to minus 6y from both sides. That gives me 3 equals y minus 1. Then we add 1 to both sides. And y is how big? Y is 4. All right, and then we need arc JK. Arc JK is the arc that's being intercepted. And angles L and M are both inscribed, so the measurement of the angle is equal to 1/2 the measurement of the arc. I can use angle L or angle M. It does not matter. I'm going to use angle M. So angle M is equal to 1/2 the measurement of arc JK. Angle M is 7y minus 1. How big was y again? So I have 7 times 4 minus 1. What is 7 times 4? 28 minus 1? 27. So 27 is equal to 1/2 the measurement of arc JK. What do I need to do now? We're going to multiply both sides by 2. So it's going to cancel my denominator. So now I don't have a denominator. Whenever the thing I'm looking for or my variable is inside parentheses next to a fraction, that's when I multiply by the denominator. If it's just numbers inside the parentheses next to the fraction, then I find that number and I take half of it. But if it's a variable or the thing that I'm looking for, then I have to multiply both sides by 2. What is 27 times 2? 54. So arc JK is 54 degrees. That is all I have time for today. The answer key for the test review is already posted. If you go to today's Canvas page and you scroll down to the very, very, very bottom, Geometry Module 10 Test Review Solutions, and click on this, it brings up all of my answers with the work. Also, if you had a question about one of the ones that we did not go over in class today, you should check out one of the 3 videos from my other 3 sections of geometry to see if maybe I went over the question in there as well, so that you can get your question answered. Test review ready to go tomorrow. This is the last test before spring break, guys.